Hello guys, good day and you are all welcomed with another lecture. Um, so let's start with today's agenda. What's today's agenda is like we are going to make a roadmap how we are going to learn machine learning. So first of all, we have listed our topics here, which we'll be covering in this whole lecture series. And after this, we will be working on some sample applications as well. We will be doing a live project as well, and then I will share my contact or Gmail with you guys, so you guys can do your own code. You can share with me. I will review your codes and will let you know about any improvements or things if needed. Okay. So this is our roadmap. We are going to read about first linear regression, then we'll be studying logistic regression, then we have our decision tree, then we have random forest, then naive bayes, and at last we will be working on sport vector machine. After sport vector machine, we will go with our live project. So without wasting time, let's start. What is linear regression? Linear regression is a type of algorithm in which we can do prediction based on our trained data set. We can do our test data set. So what is our trained data set? Our trained data set is a set of table or anything which tells us about the possibilities of a value. So suppose if someone tells us like a 500 square meter house cost us 1 lakh, and then a 1,000 square meter house cost us 2 lakh, we can easily predict like a 2000 square meter uh, house will cost us 4 lakh because it is doubling the value. So this type of prediction is the prediction which our machine can also do if we allow our machine or if we teach our machine how to make a linear regression line for this. So it is a linear approaching model. We will go into the detail in our next lectures, but for now I'm just giving an overview. The case of one explanatory variable is called the simple linear relation. Like we have an explanatory variable, like as I mentioned, 1 maps to 5, 2 maps to 10, 3 maps to 15. One can easily predict that if 3 maps to 15, then 50 will map to 250. Like each of the value is multiplying by 5. This is called the prediction which our machine can even do if we provide a detailed data set. So this is mostly working on dependent and independent variables. So the variable which we are passing and the value which we are getting are two variables. The variable which we are passing is then independent. Its value can be any, and dependent is derived from independent. So dependent's value cannot be any unless the value of independent changes. Then we have our logistic reaction. What is logistic reaction? Logistic model is a statistic model that is the probability of an event taking by having the log of event and combination of one or more independent variable. Like it tells us the possibility of an event. So what is an example of logistic regression? It is simply an example of like raining, or it's an example of like thunderstorm. So usually the people, like if we can see, this is a graph, this is the possibility of passing exam versus ours. So we know that if a student studies in some working in his hours, like studies 2 hours or 3 hours or 5 hours, as far as he increases his work studying hours, his passing chances are increased. So this is a prediction, but this is not so true, because there can be a case like if a student worked studied too much and they still failed. That is a case even that can occur, but again this is a possibility finder. So a possibility can be derived like if a student studies more hours, he has more possibility to pass, and if a student studied lesser hours, he has less possibility to pass out. So in regression or logistic regression, the estimating parameter of logistic model. So our estimating parameter here is the passing possibility. Then we have a decision tree. What is a decision tree? It is just a tree in which each node is derived from its parent node based on some conditions. So let's there's an example like if age, we are considering if age is between 30 to 40, we are making him yes, yes, you are allowed for a type of event, suppose. But if age is less than 30, we know that it is a student. If this is a student, we will ask either you want to go or no. So the yes or no are predicted from their decision. If the age is greater than 40, then we can know, yeah, this is the senior, he actually deserves a credit rating. And if he deserves a credit rating, it can go up to excellent or fair. So this is a decision tree, like each node is derived from its parent node based on some given condition. So there are multiple examples in our daily life, like we have similar type of thing, like if I wake up early, I go for a walk before going to office. But if I wake up late, I will directly go to office. This is also a decision tree. Then there is a random forest algorithm. But random forest, it is quite similar to decision tree, but there are multiple decision tree under a parent node. So this is an instance node, parent node. Based on a decision, it can result into another complete decision tree. So if a complete decision tree, and it is again derived from a node, and that node also inherits another decision tree, that is called a random forest. So multiple decision tree connected to a parent node, and at the end each decision tree comes to a final class. This is called a random forest, and this is usually profitable, or this is usually helpful in inheritance or generalization when we are doing programming. Then we have naive bias. What is naive bias? This is also famous for calling Gaussian naive bias. The Gaussian naive bias is a similar method to predict probability of different class based on the various attributes. Like given the attributes, and we can find the possibility like this can occur. Suppose if someone tells us some attributes like uh, there's a clouds outside and the wind is blowing very fast, then we can say like, yeah, there's a possibility of having rain. The rain itself has an entity of class in our system. So the algorithm is mostly used in classification with problem having multiple classes. So we pass it our data, and we pass it the type of class. Like if we pass it like there's a thunderstorm, and thunderstorm is a part of class like cold weather. Based on these prediction, it will return us like there's a possibility of having rain. So this is called Gaussian naive bias, but we will be studying about it later in detail as well. Then we have our sport vector machine. What is sport vector machine? This is the algorithm which doesn't only rely on our data set, but it also calculates the data set which we have not provided. That type of data set is called actually outliers, the data lying outside our data. So spot vector machine is a set of supervised learning method for classification, regression, outlier detection. The advantage of spot vector machine is like it is high efficient, dimensional spaces are calculated, and still effective in case where the number of dimension is greater. So if this is our data set, like this is our regression line calculated by the given data set. Based on this data set, we can observe like there can be some data lying here as well and some data lying here as well. We are able to calculate any value here 100% perfectly, but these values can also be calculated, or if not calculated, we can say these values can also be predicted with the most accuracy. Not the 100%, but we can go up to the most accuracy. What is the detail of it? How we'll calculate outliers? What are the chances of accuracy? Like how many percentage of correct data we can gather? That is a thing again we will discuss in next lectures. But this is the sport vector machine. At the end, these are our topics which I mentioned. I'll be start recording the lectures as well. Till then, if you guys like the video, if you guys need any improvement, you can let me know. I will make sure to do those improvements, please. I just have one request, please, as I am new, just want to grow, so you can please like, share, and subscribe. Because I just want to work long term on this channel, and I want to upload many other languages lectures as well, because I have expertise in those as well. Thank you guys. Have a great day. Goodbye.